right, here we go. Remember, all of this goes on to quarter 4. Quarter 3 is wrapped up. We will not submit grades until the end of this week, so just make sure you go and check and see is there any M's in the grade book that you need to get done and turned in, especially assessments. Missing counts as a 0 until taken. So find time to get all that made up, taken, so that we can have that in the grade book by the time we submit. But this exponential stuff will be the first stuff to go into your quarter 4 grade. So the notes from last week, the practice sheet from last week, and then what we do this week. So this week we're going to finish up the last little bit of notes. We have one other scenario to talk about. We're going to spend the remainder of the week doing some practice. And then on Thursday, we will take a quiz on these exponential equations. Similar length to the logarithm quiz. And again, that quiz and all of this notebook stuff will go on quarter 4. We have your logarithm notebook check-in, we have your logarithm quiz-in, and everything else from this quarter. So that, whatever your grade shows right now, if you don't do any makeup stuff for that, that's the grade you will end with. Okay? So, we have 3 problems. Last week, what were we trying to do on both sides of our equal sign? What were we trying to get the exact same? The bases. We'd get the left base exactly the same as the right base. Sometimes you wouldn't have to change either one. Sometimes you have to change one side. Sometimes you might even have to change both sides. Now, when you look at this, 7 to the 3x equals 5. What issue do you see? We have a 7 and a 5. Can you rewrite 7 as a new base? You can't. You also can't rewrite 5 as a new base. Can you rewrite the bases to be the same in this problem? You can't, right? There's nothing we can do to get the left base and the right base equal to each other. So we can't just cross out our bases and drop the exponents like last week. We can't do that. So we need a new way of solving these when this happens. So we always try to make the bases the same. If we can't, then we go to our 3 steps. We need to isolate the exponential. We need to use the definition of a logarithm, which is fancy math words for the loop-de-loop. And then we solve the rest using our calculator. Calculator is big this time. So when I look at example 4, I go, I got a 7, I got a 5. I can't make those bases the same. So I'm going to go through my steps. Step 1, isolate the exponential. Here is my base. Here is my exponent. Those are already by itself. Base, exponent. That's an exponential. It's all by itself. What I mean by isolate the exponential is, separate thing, I'm just going to make this up. If I had 3 to the 2x plus 4 equals 7, if I had something like this is my exponential. Is it all by itself on this side of the equal sign? No, I have a plus 4 also. So if you were in this scenario, your first job would be to get rid of the plus 4. Move it to the other side. Then our exponential would be by itself. In this example, our exponential is already by itself, so I get to go right to step 2. Loop-de-looping time. I need to take this exponential, and I need to rewrite it as a logarithm. That's the only way I can get that exponent to no longer be up there, attached to the base. So the loop-de-loop, we start at the base, so we are going to need to write a log with base what?
Is it log 7, 3x equals 5?
So it's going to be log base 7, little 7. That's what this 7 turned into. This 7 turned into a log of base 7. Now we start to loop-de-loop. Inside my log is going to be the 5. and then it's going to be equal to the exponent, 3x. So 7 became my base of my log. The 5 is the value that goes inside the log, and logs are always equal to whatever the exponent is. Logs find exponent. So log base 7 of 5 equals the exponent, 3x. And now you'll see 3x is not an exponent attached to a base anymore. We brought the exponent down, and we can actually do some solving. Okay? So now we need to solve the resulting equation. Our goal is to get log equals x. Is this x by itself right now? No. What do we still have? And whenever there's a 3 in front of an x, what do we usually do in an equation? You divide both sides by 3, right? Just like normal algebra. We put our little waterfall. And I know we have this ugly little log over here, but just don't worry about it for now. We're just trying to get x by itself. And I know if I have a number right in front of the x attached, I can divide both sides by it. Divide the right side by 3. Divide the left side by 3. These 3's cancel, and I'm left with just an x. The left side, this is not mental math, is it? I don't know what log base 7 of 5 divided by 3 is, so I need my calculator, and I'm going to plug it all in at the exact same time. So I'm going to pull up my calculator. We are going to plug it all in at the exact same time. See what that looks like. All right. Turn your calculators on. Can I get it to fit? All right, there we go. Okay, so watch carefully. I'm going to type in first log base 7 of 5. How do I type in a log of base 7? That's a special type of log. I have to go to math, go to the bottom on my list, and find log base, and click enter. Type in my little 7, type in my 5, and what are we going to divide all of this by? 3, divided by 3. Okay, I plugged in the entire left side of my equation because this is all going to be one number. There's no variables. So I'm allowed to plug it all in my calculator, and this is called evaluating, and I click enter. And what is x going to be about? 0.276. Perfect rounding. 0.276. That is the value of x. And we're done. This is still an exponential equation. It looks a lot like the problems we did yesterday, but because the bases can't be rewritten the same, we have to do this loop-de-loop, and we have to use a log. Okay, but as long as you know to use your log and you know how to do your little loop-de-loop, then guess what? Calculator does most of the work for us. Okay, we got 2 more. Next. Alright, we have e to the power of x minus 6 equals 150. Again, the goal here is to find the value of x. X equals something. What is the base on the left side of my equal sign? E is the base. On the right side, my base is 150. Please let me know, because I have no idea how to write E and 150 as the same base. Do you? Last week, we would have made like, 25 can be 5 to the second. Same base, cancel them out, good. Here, E and 150, I have no idea. I don't even know if you can write 150 as a base E or E as a base of 150. So, the old way doesn't work here, just like before, so we go to our 3 steps. Step 1, isolate the exponential. This is our exponential. There's our base. There's our exponent. Okay, there's nothing else on that side, so it is already isolated. The only way I can solve this is using the loop-de-loop and my calculator to evaluate. So starting with the base, what type of ln will e turn into? What type of log? Well, what type of log specifically? Like the last one, 7 turned into log base 7.
Natural log.
Yeah, the natural log, ln. So e is going to become ln. Okay, e special. A log with base e becomes the natural log, or ln. Okay, and now we begin to loop-de-loop. We start with the re, which became ln, and inside we're going to put 150. And logs, even the natural log, always are equal to whatever the exponent is. In this case, our exponent is what? So it's equal to x minus 6. And now our exponent is no longer connected to a base, which means we can start to solve this. So waterfall down the equal sign. Our goal right now is getting x by itself. So what do I need to move? What do I need to move? The negative 6. And how do I move a negative 6 to the other side? Add 6. Now, here's where I see students make the biggest mistake. Do you think you can add 6 to 150? Do you think you can add 6 to the inside of that ln? No. 150 and 6 are both normal numbers, and I agree they would be like terms, but we can't move a term to the other side and just decide to put it inside the ln or log function. So where am I going to put it on the other side? We're just going to put it at the end. So it's going to become the ln of 150 close the parenthesis, and I just add a plus 6 to the end. Okay? We're just going to add 6 to the end. Now that left side, again, I cannot do logarithms in my head. So we're going to leave that left side to the calculator. None of these are variables, so that's just a number. So I'm going to pull up my calculator, and I'm going to plug and chug. ln, 150. What do I need to make sure I do after I type in 150? Parentheses, plus 6. And the x is about 11.011. Done. That's the value of x. And look, we can even check our answer. We rounded, so it's not going to be perfect. If I were to take 11.011 and put it back in for x, second e to the power of 11.011. Now, do you have to do this? No, but I want to know if my answer is right. Minus 6. This should get me really close to 150. And look. Oh, what did I do wrong? Oh, I put 1.011. Shame on me. There we go. Really close to 150. So I know my answer is correct. One more problem. Okay. Example 6. Write it down.
It's like XP only based on what's on the back, not on columns on it.
So look.
It's the what's on the back.
I'll tell you next time. Okay, example 6. On the left side of my equation, I see my exponential. It is right here. 10 to the power of x. Now, is it all by itself? It is not all by itself. Which means we can't do the loop-de-loop yet. We need that 10 to the power of x to be all by itself. Okay? So I'm going to draw my waterfall. My goal is getting what I've highlighted green, the exponential, all alone on the left side. What things have to move? We got to move the 2. And how do I move a positive 2 to the other side? I agree. Subtract this 2. We have negative 10 to the power of x equals negative 30. All right. Now think, right now on the left side, what is our base? Negative 10. Now watch what happens if I try to do a negative logarithm. So if I were to try to do this, and I went math, went to my log base, I plug in negative 10, I plug in my other number. What happens? We get an error. Logs can't have negative bases. Okay? Logs can't have a negative base. So the question is there something we can do, or does this mean we can't do the problem? How could I remedy this situation? If I were to do the loop-de-loop right now, my calculator can't do it. What do I do about this negative? Well, I can't, remember it's an equation, I can't just change the left side. What can I do to both sides to change this into a positive? Divide by what? Well, what can I if I divide negative 10 to the power of x by 1, it's going to still be...
divide by 10.
If I divide by 10, now it's going to be negative... Well, we can't divide by 10.
Divide by negative?
Divide by negative 1. What happens when I divide this by negative 1?
10.
It becomes positive. And then we have something I can put into the calculator. If I divide both sides by negative 1, my left side becomes 10 to the power of x, positive now, equals positive 30. Now, when I start to rewrite this, so 10 becomes what? We need to turn this into a log. What type of log does it turn into? Just regular log, right? Do I even need to write the base 10? No, because it's the common log. You could write the little 10 if you want. Now I'm going to start loop-de-looping. My value on the inside is 30, and it's always equal to my exponent, which is x. So now I have log base 10 of 30 equals x. My base is now positive, which means I am allowed to plug it into my calculator. And I shouldn't get an error. So let's double check. Log of 30. Click enter. Alternatively, if you do like typing in the base, you can always also go to log base, type in your 10. Both of these will be exactly the same. 1.447. Is my answer to example 6. You can always check your answer by taking what you got in x, plugging it back into the original equation. If you were to type in 2 minus 10 to the power of 1.447, you should get something close to negative 28. Not exactly, because we rounded.
It's actually 2.
Oh, is it? Sorry. 1.477. Thanks for the correction. There you go. Yeah, if you plug that back into the original, you should get really, really close. And that is it for my examples.